Last class I told about how to find out equation of line in space. That is, in case of three-dimensional geometry, how we are finding equation of line. I told. Even along with that, I told different types of theorems also to find the equation of line passing through a point and parallel to one vector. And second theorem is to find the equation of line when it is passing through the 2 points in both vector and Cartesian forms. Even though I told some how to find out shortest distance between the two skew lines also. Today I'll tell you one new concept today, that is plane. What is meant by plane first, and how we are seeing that equation of a plane in standard form here. Plane means it is also similar to standard form of equation of line. Here also we'll see some different types of theorems. How to find out the equation of plane in normal form. How to find out the equation of plane when it is passing through a point and parallel to one vector. At the same time, when it is passing through 3 points, when it is passing through a point and parallel to given two vectors, and when it is passing through 4 points, like that. Here you will see different types of some standard conditions here. Plane means, definition for plane is, definition. An equation is of the form, that is every first degree equation. Every first degree equation. Every first degree equation. Every first degree equation is in the form of, ax plus by plus cz plus d is equal to 0. Is called equation of a plane. Whenever in analytical geometry, wherever if you can see equations like this in this form, then these types of equations are always reference equation of a plane here. That's what the standard form of equation of plane. At the same time, we can give definition for plane is every first degree equation in the form of ax plus by plus cz plus d is equal to 0, where a comma b comma c and d are the real numbers. At the same time, a comma b and c, they are not simultaneously zeros. Like those equations are called standard form of equations of a plane. Here also, in case of planes, we will see some different types of theorems here. First theorem is normal form equation of line. For this also we will give solution in both vector and Cartesian forms. First theorem 1 in case of planes. Theorem 1, normal form of equation of a plane here. Normal form of equation of plane. Normal form of equation of plane here. Normal form of equation of plane. Its equation is always in the form of r vector dot n cap is equal to p. Whenever, if you can see this equation, r vector dot n cap is equal to p, it is always a vector form of equation of plane in normal form. Now proof for this is, Here n cap is a vector of normal and base the length of perpendicular distance from origin onto that given plane here. Here we are going to give in this normal form of equation of plane in both vector and Cartesian forms. The first one is it is the vector form. With the help of this vector form, we are going to give in the Cartesian form also here. First proof for is in case of vector form, and first I am going to write the first diagram here. It is the one plane here. This is the one plane. The plane is, we consider for plane is pi here, and here one is line segments. It is n q this is, and here I am going to taking here O is some fixed point in that space. Join this O n here. Next join O q also here. It is ON is always perpendicular to NQ here. It is OQ vector means small letter R vector. And ON is length of perpendicular. We consider ON is some length of perpendicular P and its ON vector becomes P n cap here. Because for example, one is a unit vector n cap is there. Its length is some 10 units. Then that vector can be considered as 10 n cap. Similarly, in the same way, I am going to taking ON length as P, then its total length ON vector can be considered as P n cap. Now, with the help of that diagram, I am going to give you proof in both the vector and the Cartesian form. First, in case of vector form, we must get this proof, that is R vector dot n cap is equal to P here. First one is vector form. Vector form first one is. Let O is the fixed point here. Let O is the fixed points. And let ON be the length of the perpendicular from origin onto the plane pi, that is ON is equal to P here. And at the same time, we are going to writing ON vector can be written as ON vector is equal to P n cap, because it is the n cap is unit vector along the vector ON. That's what here ON vector can be written as P n cap. That is here O to n direction is ON vector is. At the same time, let Q be the a general point on the plane. Let Q be the general point. Q be the general point on the plane. On the plane pi here. With position vector OQ vector is equal to small letter R vector. At the same time, NQ vector is perpendicular to ON vector, because NQ and ON they are perpendicular to each other. Whenever in case of vectors, if the two vectors are perpendicular to each other, then we must take their dot product as 0. That is NQ vector dot ON vector is equal to 0. You consider NQ vector in terms of position vectors. Convert this NQ vector into in terms of position vectors like this. OQ vector minus ON vector dot ON vector. is equal to 0. OQ vector is R vector minus ON vector is, in case of ON vector we consider here ON vector already we considered P n cap substitute dots P n cap is equal to 0. Multiply with P n cap with R vector dots P n cap minus P into P square n cap dot n cap is equal to 0 here. Take P as a common here, then we get R vector dots n cap minus P. N cap dot n cap means 1 because n cap is the unit vector. That's what we can write unit vector dot unit vector is equal to 1 is equal to here 0. Send P that side. Already P is some length. We consider P as a length means it is the length of the perpendicular from origin onto that plane. That's why it is some constant, it is a real number. If we can send that side, it becomes divisor of 0. Then its equation becomes here R vector dots n cap minus P is equal to 0. Or you can send P that side, becomes R vector dots n cap is equal to P, which is the normal form of equation of a plane. That's what in case of vector form we considered here. We must and should get R vector dot n cap is equal to P. This is the procedure to find the equation of plane in case of normal form for the vector formation. Like that we are going to find the vector form of equation of plane, that is R vector dot n cap is equal to P, where P is the length of the perpendicular from origin onto that given plane, and n cap is the unit vector along the normal, that is ON vector is equal to P n cap. Next, let us discuss about how to find that Cartesian form of this normal form. Next, we are going to discussing about Cartesian form. Cartesian form here. Proof for Cartesian form. For this theorem is Cartesian form. Proof of Cartesian form. Proof for this, consider to take your R vector dots n cap is equal to P. Based on this normal form of vector form, we are going to giving the Cartesian form of equation of plane also here. Let Q is equal to here x comma y comma z you consider. That is OQ vector is equal to small letter r vector is equal to x I cap plus y j cap plus z k cap. It is one vector. Another one is n cap unit vector is equal to n cap is equal to l I cap plus m j cap plus n k cap, where L comma m and n are the direction cosines direction cosines of n cap. Now we are going to substitute these two vectors in the vector form of equation of plane. That is R dots n cap is equal to p. In this, we must and should substitute these two here. Or vector means x I cap plus y j cap plus z k cap dots n cap means li cap plus mj cap plus nk cap is equal to p here. Take dot product between these two vectors, that is the lx plus y into m means my plus z into m means nz is equal to p, which is the Cartesian form of equation of plane, that is lx plus my plus nz is equal to p, where p is the length of the perpendicular from origin onto that given plane. Like that, we are giving a proof in case of Cartesian form. Cartesian form means should get that proof with the help of vector form, that is the r vector dot n cap is equal to p. With the help of that, we are giving that form of Cartesian in case of to find the equation of plane here. This theorem is called as the normal form of equation of a plane. Next, let us discuss about another theorem 2. Theorem 2 here. Theorem 2. To find the equation of plane passing through a points and perpendicular to one vector, that is one normal. To find the equation of plane, to find the equation of plane, equation of a plane passing through a points, when it is passing through a points, when it is passing through a points passing through a points and perpendicular to one vector. In both vector and Cartesian forms. Vector and Cartesian forms. In both vector and Cartesian forms here. Here also, a plane is passing through a point and perpendicular to one vector here. So diagrammatically I am showing how it is passing through points and how it is perpendicular to one vector here. Proof first in case of vector form first. Proof vector form first. See, I take one plane here. It is one plane here. And plane pi here. And take one line segment here. AB is the one line segment. Here, passing through a point, the plane is passing through a point capital A. At the same time, I have taken P as a general point in the plane. Just join that O is a fixed point here and join up to OP line segment here. That is OA vector is small letter A vector and OP vector is small letter R vector. Same time, it is perpendicular to one vector n vector this is. This is A of small letter A vector, and it is the P of small letter R vector. This is. Here, by observing this diagram, if the plane is passing to the point capital A with the position vector capital A, that is the OA vector is equal to small letter A vector, and P is a general point in the plane with the position vector OP vector is equal to small letter R vector. I considered these 2 points here because the plane is passing to the point capital A with position vector OA vector is equal to small letter A vector, and let P be a general point in the plane with the position vector OP vector is equal to small letter R vector. At the same time, I have taken one vector, n vector is perpendicular to the plane. In diagram, if you can extend like this, it is always perpendicular to the line segment AP in that plane. That's what here, by this diagram, we can take AP vector is always perpendicular to the vector n vector here. Therefore, AP vector is always perpendicular to n vector here. Because if you can take like a pole to this plane, pole means it is always normal. It is always normal means it is always perpendicular. At the same time, if you can extend like this up to AB line segments, then AP and n vector, they are always perpendicular to each other. Whenever they are perpendicular to each other, then their dot product should be is always equal to 0. AP vector dot n vector is always equal to 0 here. And afterwards, we convert that AP vector in terms of position vectors like this. OP vector minus OA vector dot n vector is equal to 0. Instead of OP, we consider R vector minus. Instead of OA, we consider small letter A vector dot n vector is equal to 0, which is always represents a vector form of equation of plane when it is passing through a point and perpendicular to one vector. Then its equation is always given by R vector minus A vector dot of n vector is equal to 0, which is the vector form of equation of a plane when it is passing through a point and perpendicular to one vector. Now, next let us discuss about Cartesian form. It is the procedure of vector form of equation of a plane. Next let us discuss about Cartesian form of equation of a plane when it is passing through a point and perpendicular to one normal. Cartesian form. Cartesian forms. Cartesian form. Its equations. Let P is equal to x comma